Okay, today we're learning about the quadratic formula. Before we jump into that though, let's look at a review of last day. For this, we want to sketch a quadratic equation or sketch the parabola for this equation here. And we want to first find the x-intercepts and then the vertex, and then we're going to sketch. So how do we find the x-intercepts? Well, first, let's take a look at this equation. We have y equal ax squared, in this case a is negative 2, minus or plus bx, in this case is b is negative 6x, and there's really no plus c, there's nothing here, no third term or constant. This really represents the y-intercept. So technically, because there is none, we know the y-intercept is right there at 0, 0, but we're not going to use that method to do that just yet. I want to first take you here to rewrite the equation, and we're going to factor standard form in order to get the x-intercepts, because we know that factoring standard form gets us a root form, and the roots are the x-intercepts. So the first thing we want to do is take out the greatest common factor. In this case, it's negative 2x. Negative 2x times x represents negative 2x squared, and negative 2x times a positive 3 will get us negative 6x. Remember, for the roots, the y value is 0. To be on the x-intercept or have the roots, right? If we're on the actual, for example here, if we're on the x-axis, the roots at those coordinate, the coordinates, the y coordinate, the value of the y on this coordinate, on each of these coordinates would be 0. So that's why we call it an intercept. Where it intercepts the x-axis, y is 0, and conversely, when a line passes through the y-axis, x is 0. Okay, so we have 0 equal negative 2x times x plus 3, and in order for these two factors to multiply and get 0, either negative 2x equals 0 or x plus 3 has to equal 0. If negative 2x equals 0, then I divide both sides by negative 2, and of course I get x equals 0. And if x plus 3 equals 0, then I get x equal negative 3. So those are my two roots, 0, and let's say right about there is negative 3. Okay. Now to get the vertex, we want to complete the square, which you should be very familiar with based on last lessons. So we are going to bracket our first two terms. We only have two terms here. So y equal, I take out the GCF of negative 2 x squared, and then plus 3x, close the bracket. And the next step, we are going to halve the value of the 3. So we get plus 3 over 2 squared minus 3 over 2 squared, close bracket. Y equal negative 2 times x squared plus 3x plus 9 over 4. And now we're going to boot out that last term, but don't forget we have to multiply the negative 2 times that and then remove it. So just off to the side here, you know that negative 2 times, and we know 3 over 2 squared is 9 over 4. So we have negative 2 times a negative 9 over 4. Okay, because it's minus 3 over 2 squared, so it's minus 9 over 4. And now we have, let's see, we have negative 2 times negative 9 is positive 18 over 4, which is equal to 9 over 2. So we have, I'll do it in red for you here, minus 9 over 2. Then we have y equal negative 2. We can square root the x, and we're going to square root 9 over 4, which is really 3 over 2 squared minus 9 over 2, or 9 over 2 is negative 9 over 2 is really 4.5. So you can, for the purpose of graphing this, you may want to write negative 2 x plus, this is really 1.5 squared minus 4.5. So our vertex is negative 1.5, and that makes sense because we have 0 and negative 3, so in the middle would be negative 1.5, and then negative 4.5. Let's just say somewhere like that. And we're going to sketch our graph. We missed a little bit there. Something like that. And there's your parabola. All right. Here are the learning goals. A quadratic equation in standard form can be solved for x using the quadratic formula. which I'm going to show you in a second. But it's very important that you see page 293. On that page of the textbook, it shows you that when you take the equation y equal ax squared plus bx plus c, and you complete the square, you can basically rearrange this formula so that you have x equal, and you have a formula for the roots. And that's the formula I'm going to show you. But it's important to understand what I just said by reviewing page 293. You can also, based on that formula, determine that the x-coordinate of the vertex of a parabola, which is also the axis of symmetry, right? So for example, this parabola here, the x value is really, we know x equal -2. That's the axis of symmetry for that one. You can also find that by using this mini version, or a piece of the quadratic formula, -b divided by 2a. And so a, b, and c are really right here. So ax squared, that's your a value, right? Plus bx, whatever this is, plus c, and whatever that is. So if you take a negative value, or the opposite value of your b, and divide that by 2 times whatever your a value is, you can quickly get the x value of, get the axis of symmetry, or the x-coordinate of the vertex. All right, how many zeros, or how many roots, does each of the following parabolas have? In the first parabola, we notice that there's just one root right there. So we'll say 1. In this parabola, we have 2 roots, 1 and 2. There they are, 1 and 2. And in this parabola, we have no roots, or 0 roots, because it does not pass through the x-axis. So at most, you can have 2 roots, right? So a parabola, or an equation, can have at most 2 roots. It could have 0 roots, it could have 1 root, or it could have 2 roots. Keeping that in mind. All right, so if we're going to solve this, we want to find the roots, of course. One way to solve is the way you've been used to, which is factoring, by factoring regularly if possible, and then if not, completing the square. But we can factor here. So we're looking for, we're looking at 2 times -5. There's no GCF, so 2 times -5 is -10. So we're looking for a times c equal -10, but we want a sum has to equal +3. Well, +5 times a -2 equal -10, and a +5 plus -2, or -2 in this case, is equal to +3. So our numbers are 5 and -2, just to give you a quick refresher. So we're going to write y equal 2x squared, and we're decomposing the middle term here. 2x squared plus 5x minus 2x minus 5. We just broken down that middle term. Y equal, and we're going to GCF these two terms and GCF these, and the greatest common factor here is x. So I'm left with 2x plus 5, and then minus 1 times, of course, 2x plus 5. So y equal 2x plus 5 and x minus 1. And so for the roots, y equals 0. You can even write that in here. That'd be good form. For the roots, 0 equal 2x plus 5, x minus 1, and then we know that 2x plus 5 equals 0, or x minus 1 equals 0. In this case, I'd get 2x equal -5, and then divide both sides by 2, and then x would equal -5 over 2. That's 1. And then here I just get x equal 1. So my two roots are -5 over 2 and x equal 1. But using the quadratic formula, here we go. So my equation is y equal 2x squared, and it's plus 3x and minus 5. Just double check it. Plus 3x minus 5. Now we're going to use the quadratic formula, and that looks like this. It might seem daunting at first, but don't be afraid. This will actually be your friend. You'll appreciate this formula soon. And the quadratic formula, first, before we write that, I want to write this down. So I know the a value is equal to 2, the b is equal to +3, and the c value is -5. The quadratic formula looks like this. -b plus or minus the square root of b squared minus 4 times a times c, and the entire thing is over 2a. Again, consult page 293. We're going to sub in negative b. So in this case, b is 3. So I have negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4 times, and a is 2, c is negative 5. The whole thing is over 2 times a, which is 2 in this case. Now I have x equal negative 3 plus or minus, and we can simplify what's under the square root. 3 squared is 9 minus, careful here, 4 times 2 is 8 times negative 5 is negative 40. So I have minus negative 40. This is where a common error occurs with most students. Because you have subtract negative, you really understand that needs to be a positive here. So minus 4 or subtract a negative would be positive, in this case 40. And then that divided by 4. So x equal, we have our two roots, which are really negative 3 plus or minus the square root of 49 divided by 4, or we can have x equal negative 3. I apologize, I should let this as positive. So this is negative 3 plus the square root of 49, or x equal negative 3 minus the square root of 49 all over 4. Okay, so now we have x equal negative 3 plus 7 divided by 4, or x equal negative 3 minus 7 over 4. Now we have x equal positive 4 over 4, which is equal to 1, so that's one root. Or we have x equal negative 10 over 4, but if you reduce that, you get x equal negative 5 over 2. And you'll notice that negative 5 over 2 and 1 were the same roots that we got over here, negative 5 over 2 and 1. So that's the quadratic formula way of doing it, much quicker. And like I said, that'll be your friend when you're finding factoring difficult. All right, see you in class.